Hi, I'm Derek Reister, and I'm doing my thermodynamic project on the drip coffee maker. So first of all, I'll start with a simple description of the operation of the coffee maker, and then I'll go through the concepts which I think this coffee maker exhibits. So first of all, you're going to put water into this reservoir. This water will just be room temperature water, or whatever water you have. After the water is in the reservoir, it will go to the bottom through a tube and then run through the base of this, where in the base of this coffee pot there is a heating element. This heating element will heat up the water to a boil, and then this water will go through a bubble tube, which I'll explain the specifics of the bubble tube a little bit more later, or bubble pump a little bit more later. It's a very interesting thing. Up to the top of the coffee maker, which you'll see we have a shower head-like device, is the best way I can think of describing it, which will distribute the hot water onto the coffee grounds, and then the coffee will drip into the coffee pot. This is where the name drip coffee maker comes from, as the coffee will just slowly drip into your coffee pot. This is one of the most common coffee pots you can find. They're very simple, very easy to manufacture. And as I go through it, I'll explain all the parts to it. And it's, yeah, like I said, it's a very simple contraption. There's not a whole lot to it, but that's what makes it such a popular coffee maker. So the first concept that I think this coffee maker exhibits is a closed system. To preface this, we're going to be looking at this coffee pot, this coffee maker, and the coffee pot at the bottom as one system, as the argument could be made that they're two of their own different separate systems in which mass is being transferred from the coffee maker to the coffee pot. However, I'm going to keep things simple. I'll be just looking at the entire thing as its own system, so there'll be no mass transfer out of the coffee pot. There will, however, be a little bit of energy transfer in the form of heat out of the coffee pot, but that is allowed within closed systems as long as there is no mass transfer. There might be a tiny little bit of steam that escapes while the water is boiling, but for all intents and purposes, this coffee maker is a closed system. So for concept 2, I'm going to be looking at heat transfer, which this coffee pot, its main function is warming up water and turning it into coffee. So there will be a little bit of heat transfer. All the heat transfer is going to happen at the bottom of this coffee pot. Like I said, there's a little heating element that's shaped sort of like a horseshoe. This element is made out of copper or aluminum coils, very similar to the filament in a light bulb, which makes it really simple and why this coffee pot is so cheap. It's such a cheap little heating element. So basically, power will come from the wall into that heating element, run current through it, and that heating element will act as a resistor. And then as the current's running through the resistor, it generates heat. And that heating element will boil the water, which will be brought up through the bubble pump, which, like I said, I'll explain a little bit more in depth later. It's very interesting. And that heating element will also be used to keep the coffee warm after it's been made. It's a very clever design. The heating element is actually sandwiched in between this little steel plate underneath the coffee pot, and there's a little tube in which the water runs through and where it gets boiled. So that heating element serves two purposes. It can keep the water hot, and it can boil, or keep the coffee hot, and it can boil the water initially. It does this in both cases by convection. The water is in contact, so contact heating. The heating element will, as the water is coming in contact with that heating element, it will put heat into that energy into that water and then cause it to change state or boil. It's similar with this. It's just a steel pad or aluminum pad here that the heating element will just convect heat into, and that's basically how it stays warm. It's a rather simple system, but it works very well. So the third concept I'll be discussing is phase change. And when you have a coffee pot like this, a drip coffee maker, phase change is imperative to the design. It's actually, this is where the bubble pump comes in, which I think is one of the most interesting parts of this coffee maker. So basically, after the water gets boiled by the heating element about right in here, there's a little bit of a tube, and you can't really see it without taking the coffee pot apart. And unfortunately, I don't really want to take the coffee pot apart. I don't want to break anything. So there's a little bit of a tube. It has a one-way valve, so the water can only flow up the tube boiling water cannot come back into this little reservoir down here, or possibly come back into this reservoir. So this tube runs up to the top to that shower head fixture right here. And basically how this tube works, as the water is a liquid and it's going down here, it will get changed into a mixture of a liquid and a vapor. The water will start boiling. And that boiling water, this tube is a smaller diameter, not too big. That boiling water, the water vapor from that boiling water will want to rise. So the coffee pot takes advantage of that boiling water. This tube, the vapor will start going up the tube, but as the vapor is going up the tube, it will carry little bits of water up the tube with it. And eventually it creates like a pump-like effect, which carries all that boiling hot water to the top of the coffee pot. It's actually also what gives the coffee pot its distinct gurgle when you're making coffee and you hear that thunder-like noise. That's actually the bubble pump. That's the water coming up from the bubble pump, which I thought was really cool. It's really ingenious. It means you don't have to have any electronics in the bottom here. Keeps things really simple, and like I said, keeps things really cheap. So for the fourth concept, I had to get a little bit creative, as the coffee pot itself is a closed system. I wouldn't consider this thing a control volume, as mass isn't coming in and mass isn't coming out. So I'm going to take a look at just an individual component of the coffee pot that I think embodies a control volume rather well. And I have chosen this shower head like device, which distributes the water on top of the coffee grounds. So the interesting thing about this is it has one inlet tube, and that comes from the bubble pump to the bottom. And then it will have several, it depends on the coffee pot, but usually it will have 5 or more little exit holes. So it'll have one inlet and several exit holes, which distribute the coffee onto the top. Now, the important thing about this is when it's being designed, they have to make sure that the flow into this can flow out just as easily, and that water doesn't get caught up in this and then want to flow back down the bubble pump, because then you're going to have a bunch of issues. Even though there is a one-way valve here, you're still putting a lot of adding heat and strain on the rear areas, which, if you don't have to do that, then it's best not to do that. So when designing this, they had to make sure that this one inlet and these outlets had the same input and output. So the water flow stays consistent, it's always flowing, there's never any hot water sitting in this piece. And then that just helps with heating and keeping the components in good working condition. So the fifth and final concept that I think this coffee pot embodies is that this coffee pot has both a reversible and, I would say, technically a reversible process. I'll explain that a little bit later. So for the irreversible processes, the first irreversible process, we'll start from the bottom here, is this heating element taking electricity from the wall and turning that into heat. That is an irreversible process. You can't unheat the element or do anything like that. So that process, as it's happening, there's inefficiencies in it. It's irreversible. The second one, I would say, is the coffee actually being made. When you have the coffee, your end product, you can distill the water or the coffee down to water and maybe some grounds, but you're never going to come back to the complete normal grounds that you had initially before you put the boiling water through the coffee and mixed it together into coffee. And now for the reversibility or reversible process that I think that is really interesting in a coffee pot, just to show that there's all kinds of processes in it, is the boiling of the water. Technically, it's a reversible process, as the water can condense and go back into a liquid. In the real world, it's not really a reversible process, as there's, like I said, there's inefficiencies with that. But I thought it was just a cool example, theoretically, that to show that there's both reversible and irreversible processes in this coffee maker.